Hey, this is Mary, and it's time for another magical math moment. This video is going to be looking at adding and subtracting rational expressions, and this is also going to involve some complex fractions. So let's get to it. Remember that to add fractions or subtract them, you need a common denominator. Now, when you've got something like a small number like 3, you always want to check to see if it will go into the larger denominator. So 3 is a factor of 12. So I can easily rewrite this 3 as a denominator 12. 3 goes into 12 4 times. 4 times 2 is 8. So I end up with 8 over 12 plus 7 over 12. Hopefully you remember here, we're just gonna go ahead and add across over 12. Since this is designed for Algebra 2, we can leave improper fractions, not a big deal. Now, another way to think about this, if you want, is what are you gonna multiply this fraction by to get an equivalent fraction over here? So I note that to get 3, I've gotta multiply by 4. What I do on the bottom, I do on the top. 4 times 2 is 8, 4 times 3 is 12. So if you prefer that way of thinking about it, that's totally fine. Let's try one where it's a little bit trickier. 5 is not a factor of 8. So in this situation, your lowest common denominator is going to be their product, 8 times 5. Okay, so I'm going to have to convert this into a denominator of 40. All right, well, what am I going to multiply 8 by to get to 40? 5. What I do on the bottom, I do on the top. Similarly, over here, I already have a 5. What do I multiply 5 by to get to 40? 8. Okay, let's multiply across and see what happens. 5 times 3 is 15. 5 times 8 is 40. Negative 2 times 8 is negative 16. 5 times 8 is 40. We're going to go ahead and subtract. 15 minus 16 is negative 1 over 40. Okay. Some students like to kind of think of it like a cross multiply situation to get 3 times 5, 15, 2 times 8, 16. I hesitate to use that because cross multiplying really only happens in proportions. This is just an expression. So we don't really want to think of it like that, but that's kind of the process you do. All right, let's throw some variables into the mix. So the first thing I need to do is consider the lowest common denominator. So I have a 3. Okay, I have an x. All right. Now once I get over to here, I've got 9. I already have 3, which is a factor of 9, right? So if I kind of rewrite it, since they have this 3 in common, I've already stated it. I don't need it again. However, since I have an extra 1 over here, I am going to have to multiply by another 3. Kind of the same idea here for the x. This is x squared, which is x times x. They have an x in common. This has an extra x, so I need to multiply by an x there. And then finally, there's a y. So if I multiply all of this nonsense, I end up with 9x squared y. So we want to look at what is going on in the original fraction. So I'm going to rewrite it again. So I've got 3x. Over here, I have 5x, 9x squared y. Okay, so we need to figure out what we're going to multiply by to get this lowest common denominator set up. So I have a 3 already. To get to 9, I need to multiply by another 3. I have an x. I need x squared, so I have to multiply by another x. I need a y, so I'm going to multiply by 3xy over itself. That is going to give me a new first term once I multiply here of 6xy over 9x squared y. I'm also going to have to multiply here. I should have left myself some room. 9x squared y. Oh, wait. I don't really need any more room because it's already all set up. So this is just 5x over 9x squared y. Okay, the last thing to do is put them together, 9x squared y. I have 6xy plus 5x. The only other thing that I would suggest you do is to factor an x out. So we've got 6y plus 5 over the 9x squared y. You always want to factor these things because sometimes things will cancel out. So I have a monomial over a monomial, so I can simplify with this x over x squared. That's going to go, and that turns into x to the first. This leaves me with 6y plus 5 over 9xy. Okay, that was a little wild. Let's try one more. Actually, I lied. 2 more. So we've got this guy first. We have x plus 5 on the bottom. X squared minus 25 is the difference of squares. X plus 5, x minus 5. Okay, so I can kind of cross that out since that's my new denominator there. So now I'm looking for the LCD. So over here I've got an x plus 5. They have that in common. It only needs to appear once. I'm missing x minus 5. Okay, so I'm going to start with rewriting this. X plus 5 minus 2x over x plus 5, x minus 5. Okay. If I consider the lowest common denominator up here, I have an x plus 5 in the initial fraction. I don't need another one. I do, however, need to contend with this x minus 5. What I do on the bottom of the fraction, I do on the top as well. X plus 5, x minus 5, I don't have to do anything here. Okay. Actually, I'm going to go under, so I have more room. I'm going to backward distribute this 4 in, so I've got 4x minus 20, and then minus 2x. This is all over the LCD of x minus 5, x plus 5. Let's combine like terms next. So I have 4x minus 2x. That's 2x minus 20. Again, over this whole thing. Okay. And finally, at the end, I'm going to factor a 2 out. 2x minus 10, x minus 5, x plus 5. And that's really all I can do. Okay. Now again, if your teacher's asking you to list domain restrictions, you always want to look at what you end up at. So in this one, x could not be 5, x cannot be negative 5. I sometimes forget to do that. So be mindful. All right, here's the last one. Best for last, right? Something like that. This is a complex fraction. So this is fine up top. I don't need to worry about doing anything to that. I'm gonna leave it alone. 7 over the quantity x minus 2. On the bottom down here, I've got some thinking to do. This is the difference of squares, x plus 2, x minus 2. Okay, so we're going to have to figure out what we're going to multiply by to get to our LCD. We have an x plus 2. Oh, I also have an x plus 2 there, so I have that in common. The only other thing missing, x minus 2. This first fraction has the x plus 2, it needs the x minus 2. So we're gonna go x minus 2 over itself. Ooh, can I fit it? I think I can. I'm then going to backward distribute 4x minus 8. 4x minus 8. And I have a plus 8x. Notice that the common denominator is already there, so I don't need to adjust this one at all. So I'm just going to do that and put it over the whole LCD of x plus 2, x minus 2. Okay, that was wild. Let's keep going. So I can't do anything with this nonsense up here. 7 over x minus 2. I have a 4x and an 8x, that's a 12x minus 8. That is over x plus 2, x minus 2. Now, you may know this little shortcut to reducing things. If you're dividing a fraction by another fraction and they have common quantities, I guess I could say, on their denominator, they cancel. So I see that I have x minus 2, that's gonna go, which makes life a little bit easier, I suppose. So now I am ending up at 7, or 7 over 1 if you prefer, over 12x minus 8. I'm going to factor a GCF of 4 out of there. So I've got 3x minus 2 over x plus 2 left. Okay. All right. The only other thing to do is to break this apart from being a complex fraction. So I am going to multiply the top by the reciprocal of the bottom. So I'm going to come over so I have space for that. 7 over 1 times x plus 2 over 4 times the quantity 3x minus 2. Now nothing is going to cancel out here. Let's pretend for a minute we had something like an 8 up here. I could do 8 over 4 is 2, but 4 isn't going to go into 7 evenly. So we're just going to leave it alone. So I've got 7 times the quantity x plus 2. On the bottom, 1 times 4 is 4. Quantity 3x minus 2. And that's that. Don't forget your domain restriction. X cannot be equal to 2/3. And if you're not sure about what I'm doing there, I'm just taking this and setting it to 0 and solving, right? So 3x is 2, x is 2/3. So when x is 2/3, you get a 0 in the denominator, which we know is no good. It gives you an undefined situation in math. So I hope that this explains it a little bit better for you. This is one of those kind of strange topics in Algebra 2. So if you're struggling with this, that's normal. Just keep practicing, go back and watch this over again, pause so that you can try and figure out some of this on your own, and then listen to my answers here to make sure you got it right. Thank you so much for watching. I'll see you next time. Bye.